Hey everyone, in this video we're going to be talking about equations and inequalities involving absolute value. So we want to solve equations and also inequalities. So to begin, let's start with the theorem for what the absolute value means. So if you have a positive number a and you have your absolute value, so that's these vertical bars right here, then what this means is absolute value of u equals a, which is always positive. And originally you could have been negative or positive, but when you take the absolute value of it, it turns positive. So essentially, if you have something negative and you take the absolute value of it, it turns positive. If it was already positive, it just stays positive. And the reason for this is because the absolute value bars, they actually represent distance. So it's letting us know how far that number is from 0 on the number line. So if I place 0 right here on my number line, then negative 5 is 5 units away from 0, and positive 5 is also 5 units away from 0. And so the absolute value, when we take that of a number, it's letting us know distance, and that's why it's always something positive. Okay, so we're going to solve our first equation. Absolute value of x plus 5 equals 15. So we're going to apply our theorem to this, and there's two possibilities. What was in the absolute value initially could have been positive 15, or it could have been negative 15. So you always set this up where you break it into the two possibilities, and then you just solve each one. So if you subtract 5 from both sides, you get x is 10, and on the other one, x is negative 20. Both of those are the answer, and so you list them as a set of answers. So the solution set is the set containing negative 20 and 10. And if you want to check, just to show you that this would work, if you plug them back in one at a time, notice what you would get. This says absolute value of negative 15, which turns that into positive 15. That one works. And if you checked 10, that of course would also be 15. Absolute value of a positive number just stays positive. Alright, how about this one? So this one's slightly different. In order to use our theorem, we have to move that 6 out of the way first. So if we subtract 6 from both sides, then we can use our theorem, because you have to do what's called isolating the absolute value. So isolate the absolute value quantity first, and then you split. So you do this first, and then you can split into the two cases, the two possibilities. So now that this absolute value quantity, this part here, is alone, we moved over that 6 by subtracting. Now we can split into the two possibilities. One where the quantity inside the absolute value bars equals positive 3, and the other one where the absolute value quantity, originally what was in there, is negative 3. And then you solve each one. So we'll just subtract 1 on both of these from both sides, and then divide by negative 2 on both of them, and then you get two answers, negative 1 and 2. And again, as always, you can check by just plugging your numbers right back into the original, right where there was an x. Alright, so now we're going to change it up a little bit. We're going to be solving absolute value inequalities. So notice this is no longer an equal sign, it is an inequality symbol, and when we have these, it does matter which way they face. So we'll do an example of each direction. Alright, so this one says we are looking for points on our x-axis, or our real number line, that are less than 3 units from the origin. Because notice this says the absolute value of x is less than 3. So that distance, we're looking for x that's less than 3 away from 0. Okay, so on our number line we place 0, and we say, well, 3 is 3 units away, and negative 3 is also 3 units away. But this says anything less than 3 units away. So negative 2 works, negative 1 works, and everything in between, all the decimal numbers in between work, and also on the positive side. So for these inequalities, we're actually going to get an interval as an answer. So you're going to get an interval, or a solution that's like a range of values. So anything between negative 3 and positive 3 is our answer for this inequality. And this is interval notation for the answer. start at -3 and then pick any number between that and +3, and that's where we would stop. Okay, so let's break down what we just did. So if we have our absolute value is less than some number or less than or equal to that number, then what you do is you break it apart as the number that we're looking for, u, is between -a and +a. Same thing with the equal bars situation. Okay, so u is greater than -a but less than a, so it's in between them. And that's another way to say this statement right here. So u is greater than -a and u is less than +a is the same exact thing as this right here. Okay, so the word and connects these. These both have to be true because I have and. This first one and this second one. And so that's what it looks like on our number line. Absolute value of u is less than or equal to a means that we're between -a and +a. Okay, let's go ahead and solve this one. So we have absolute value 2x plus 3 is less than or equal to 6. Notice that we already have our absolute value quantity isolated, so we can jump right into the form where we could split this up. So this is 2x plus 3, our quantity inside our absolute value, and it's less than or equal to +6, but greater than or equal to -6. And so we still split this into two situations. So technically it's like this. -6 is less than or equal to 2x plus 3, and 2x plus 3 is less than or equal to 6. But we write them together like this as a more condensed form. So these are equivalent. What I have here is equivalent to what I have here. This second one is just more condensed, so we're going to go with that. Okay, and then you just solve all at once. So we have a 3-part inequality, and so just solve it using what you can to isolate x. So let me get rid of some things here. And so notice what we do first. If we want to focus on getting x by itself, we would subtract 3 from the middle, but also from the left and the right. And then the last step is to get x by itself, so just divide by 2, but do that to the left and right as well. And so if we divide by 2, then our final answer, x is between -9/2 and +3/2. And so x is greater than or equal to -9/2 and less than or equal to 3/2. So here's what it looks like as a solution set in set builder notation. This says the set of all x's such that, this vertical line means such that x is between those values, but this is what we would want in an interval notation. So this says that on our number line we start at -9/2 and we stop at 3/2, and we want all the numbers in between because all those numbers would satisfy our inequality. Okay, so this is what it looks like as a graph. -9/2 is -4.5, and 3/2 is 1.5 or 1.5. And so any number in between that you want to choose in between these two would satisfy your original inequality. And if you're not sure, you could check by just plugging it in. Pick anything you want in between these numbers and it'll work when you plug it into your inequality. Okay, let's try this one. So solve absolute value 1 minus 2x is less than 3. Okay, so we know that we can split this up, and 1 minus 2x is less than 3, but it's greater than -3 because we want this to be 3 units away from 0, and so it could be at +3 all the way to -3. So that's why we have to split it into 2. And then let's just work on isolating the x in the middle. So subtract 1 from the middle and also from the left and right. And then we have just -2x in the middle. And remember, when you're working with inequalities, if you ever divide or multiply by something negative, you do have to flip the symbols. So anytime you divide or multiply by something negative, you have to flip the inequality. So flip symbol, your inequality symbol, if you divide or multiply by a negative number. This is the only thing that you do different with inequalities. than if you had just a regular equal sign. So that's because right here we divide by -2. And so notice our inequality symbols got flipped, and then we have in the middle x, and then now it says that 2 is greater than x and x is greater than -1. So for our final answer, we actually don't want to leave it the way it's written here, because we always want to rearrange it to where the smaller numbers first. And so just rotate this statement around. This says that 2 is greater than x, so this says the same thing. 2 is greater than x, or x is less than 2. And then this right here says x is greater than -1, and that's what this says right here. X is greater than -1, or -1 is less than x. And so here's our answer as a solution set, and then also as an interval, saying that we start at -1, but we stop at 2. We want everything in between. And then remember, we've talked about this in the past, but we use parentheses anytime there is no equal bars. So use parentheses if you don't have equal bars on your inequality symbols. And if you have the equal bars on your inequality symbols, that is when you use brackets. So we are using parentheses this time. So anything from -1 to 2 will work if we plug in those numbers into our original inequality. It will satisfy that inequality. Let's go ahead and check on this one just to show you that anything we pick in this interval will satisfy our inequality. So this is what we started with, and we concluded that the solution set is from -1 to 2. And so let's just pick something. Let's pick 0. So if we pick x is 0 and we plug it in, so we're still questioning if this is going to be less than 3. So we have 1 minus 2 times 0, which is just 1. And absolute value of 1 is 1. 1 is less than 3, and that's correct. And so we picked something in this interval, and it did satisfy our inequality. Alright, let's try a different one. And this one's different because notice the symbol, we're saying that now absolute value of x is greater than 2. So that's a little different than what we've been doing, because now we're looking for some value of x that's more than 2 units away from the origin, from 0. And so that could be, again, 2 situations, but this time they're split because we want to go past the 2. So on the right, if I start at 2 and I pick any number over here, these are all more than 2 units away from 0. But also on the left, if I start at -2 and pick any number over here, these are also more than 2 units away from 0. So as long as I don't pick anything in here, then I'm going to satisfy this inequality. And so when we're solving these ones, we have to have an interval considered on the negative side or the left, and then on the positive side. And so the answer is anything from -infinity to -2, and then jump over this middle section and then go from 2 to infinity. And so interval notation, again, we start at -infinity, we pick anything we want up until -2, we jump over to +2, and we pick anything we want until +infinity. And then we use this symbol in between. This is the union symbol. This is another way to say or. Okay, it's a union symbol or, uniting these 2 separate intervals. So here is how this breaks down when we have greater than. So u is greater than a, or absolute value of u, excuse me, or absolute value of u is greater than or equal to a, is going to split into these 2 cases where u is less than -a, or u is greater than +a. And very similar with the equal signs on there, on the inequalities. And so this splits your interval, something less than -a over here and something greater than +a over here. And so that's why it's one or the other one. Okay, so let's go ahead and solve this inequality. So we have absolute value 4x minus 10 is greater than 6. So we're looking for this to be greater than 6 units away from 0. And so we're going to split this up. And this time we can't combine it. So with the one where we were doing less than, so quick reminder, when we had absolute value of u was less than a, we could combine that and do this all at once. But the reason is because we were between -a and +a. But this is not between anything. We have on the left of -6 and then on the right of +6. So we can't combine these. We actually have to solve them separately. So we have one inequality here or this other inequality here, and we solve each one. So we have to split into two and solve each one, and then put the word or in between so you know that they are separate. So on each one we'll just add 10 to both sides, and then same thing on the second one. And then if we simplify, we're going to get 4x is less than 4 on the first one. This is what I'm calling the first one. And then 4x is greater than 16 on this one over here, which was the second one. Then just divide both of them by 4, and you'll get x is less than 1 or x is greater than 4. And notice that these actually don't overlap, so that's why we're saying one or the other. And so on the number line, that would look like anything less than 1, so from -infinity all the way until 1, or anything 4 or more to +infinity. And so this is what it would be in interval notation. Okay, so that's pretty much it for solving our inequalities with our absolute value and also our equations for our absolute value. Someone taught me this a while back and it kind of stuck with me, so I just want to share it with you all. It might help you a little bit. So if you had absolute value of u is greater than a, and then you had absolute value of u is less than a, what they told me, so and when I read this out loud, I said greater than. They said to say greater, but greater, because this is the or situation. This one is going to split into u is less than -a or u is greater than +a. And then this one, when absolute value of u is less than a, what they said to say was say that this is less than, put an and on the than, so less than, and so that's an and situation. So u is greater than -a and u is less than +a, which when you put those together, that's just u is between -a and +a. So that might help you remember these, or you can just sort of think about what it's saying. If you're greater than some number a, you're going to split into the two separate intervals like we had, or if you're less than some number a, then you can combine that one. Alright, that's it for this one. Thanks for watching.